All right, so in this lesson, we are going to practice writing equations for each situation. And in each situation, there's going to be two equations. And so a couple rules when you're writing your equations for systems is you only get two variables. Those variables can be x and y, they can be s and f, a and b. It can be more meaningful. I like using x and y if I'm solving, but sometimes they use other letters to be more meaningful. Okay, and the other thing you need to know about these systems of equations is you're going to come across three different types of equations. The first type will be a total. And so if you're given a total and it seems like you have two rates, total and two rates, that screams standard form. So it's going to be some number times x plus some number times y equals that total. The other type that's going to be familiar is if you have one rate, which would be your slope, and a fixed amount, which would be your y-intercept. Then that screams slope-intercept form because you have your slope and y-intercept. The third and final equation you're going to run into is a comparison between your two variables. And when you have a comparison, it's going to be the first variable mentioned equals the comparison, and that'll make more sense once we do some examples. Okay, so I'm going to color code them, and so whenever we get a total, I'm going to highlight it green. Whenever we get a comparison, I'm going to highlight it pink, and whenever we have a slope-intercept form with one rate and a fixed amount, I'm going to highlight it blue. Okay, so number one says there are twice as many sophomores than freshmen in this classroom. Okay, and then there are 12 students in the class. And so this is where I want to identify what my variables are. We're talking about sophomores and we're talking about freshmen. And so if I'm picking my variables, you can pick S and F for sophomores and freshmen, or you can pick X and Y for sophomores and freshmen. The thing you don't want to do is pick a third variable for students. Okay, so we have sophomores and freshmen. You only get two variables from these. You're not going to have a third variable for students. So X is going to be the number of sophomores. Y is going to be the number of freshmen. That's the variables we're dealing with. Okay, and so this sentence that says there are 12 students, that's a total. And so I don't know the number of sophomores and I don't know the number of freshmen, but if I add them together, X plus Y, I'm going to get a total of 12 students. Okay, and so once you use that 12, you're not going to use the 12 in the second equation. You only get to use each number once. Okay, and then my second equation is also going to be an equation involving X and Y. You only get two letters. And so the other equation comes from the first sentence that says there are twice as many sophomores than freshmen. And so when you have a comparison like that, there's twice as many sophomores, whatever comes first, in this case it's sophomores, it's X, it's automatically going to be X equals. Okay, automatically, X equals, and it says there's twice, and so 2y. A lot of people switch those. And so the trick of whatever comes first in the sentence, it's going to be that variable equals. Okay, because there's more sophomores. There are twice as many sophomores. There are more sophomores. That means I have to multiply the smaller number, which is freshmen, by 2. I don't want to multiply the sophomores by 2. Okay, and so those would be your 2 equations for number 1. Okay, number 2, it says you are buying donuts for the class. There are 30 students. You need to buy 3 times as many regular donuts as chocolate donuts. Okay, and so regular and chocolate are our 2 variables. Okay, we can use X and Y again, or you can use R and C. And so I'm going to use R and C this time. R, C. So R will be the number of regular donuts. C will be the number of chocolate donuts. Now, I don't know how much of each I'm getting, but I've got a total. The total, I'm using green for that. So there are a total of 30 students. That means I'm going to need a total of 30 donuts. So when I add R plus C, I should get a total of 30 donuts. Okay, the other sentence is a comparison between the number of regular and chocolate. It says you need to buy 3 times as many regular than chocolate. Regular comes first in that sentence, so it's automatically R equals, and the comparison says 3 times. Okay, C equals 3R is going to be an option, but R equals 3C is what we want. Regular comes first in the sentence, just like sophomores came first in the first one. All right, next up, a 40-question test has multiple choice questions and short answer questions. Multiple choice questions are worth 1 point and short answers are worth 5 points. The test is worth a total of 100 points. So in this one, we have 2 totals. Okay, and so first of all, we're dealing with multiple choice questions and we're dealing with short answer questions. So if you want, you can use M for multiple choice. That would be the number of multiple choice. And S would be the number of short answer. I'm going to specify that it's not just multiple choice, it's the number of questions. Okay, and so it says there are a total of 40 questions. And it's worth a total of 100 points. Okay, and so if I add M plus S, it's not 100. Okay, remember M represents the number of multiple choice questions. So if I add M plus S, I should get a total of 40 questions. Questions plus questions equals questions. You don't want to say questions plus questions equals points. That's a common mistake. If I want to equal the 100 points, I have to put their point values on it. And so multiple choice are 1 point each. Short answer questions are 5 points each. So 1 times M plus 5 times S equals 100. If you're using S as a variable, make sure your 5 and your S look very different. So your 5 needs to be kind of square and your S needs to be super curvy. All right, and then also if it's 1 in front, they may not write the 1 and just put M plus 5S equals 100. All right, this next one says Jerry wants to buy a new gym membership. One membership costs $40 and $10 for each class. Then the other membership costs $170 and he can attend unlimited classes. So this is a fixed amount and a rate of change. So I'm going to highlight this one blue. And so the first gym membership costs $40 and $10 per class. Okay, the other membership is just a fixed rate of 170. So this is a y equals mx plus b situation. In this case, x is the number of classes and y is the total cost. The total cost depends on the number of classes. And so that first equation, the first gym membership, costs a fixed rate of $40 plus $10 per class. So you can write 40 plus 10x, or you could write 10x plus 40 if you want to put it in slope-intercept form. The second membership costs 170 flat, not per class, 170 in unlimited classes, so it doesn't depend on classes. X isn't even a part of that equation. All right, this next one is similar as a slope-intercept form equation. It says Jeremy is trying to figure out which car dealership he wants to work with. He can go with company A that pays $460 flat plus 6% commission. Company B pays $350 plus 8% commission. And so our fixed amount is $460 plus 6%. The second equation is $350 plus 8% commission. And so in this case, commission is what you earn on how much you sell. So if I sell $100 worth of stuff and I earn 6% commission, I would figure out 6% of 100 and I would make $6 on that sale. And so X is the amount of sales, and then Y would be his total paycheck. So both are money. Okay, and so for the first company, he's going to make $460 no matter what, plus 6% commission. So if you need to figure out 6% as a decimal, it's 6 divided by 100. Percent means per 100. And so 8% would be 8 divided by 100. If you type that into Desmos, it's 0.08. If you type 6 divided by 100, it's 0.06. And so 0.06 times the x would be your slope. And then for company B, he's making $350 flat plus 8% of his sales. So y equals $350 plus 0.08x. The x goes with the percent. That's your slope. You were trying to decide which cell phone plan to go with. One plan costs $60 plus 5 cents per minute. Minute would be your x. Per minute you are using data. The other plan costs $200 for unlimited data. So this is kind of like the gym membership. The first plan has a fixed rate of 60 plus 0.05 per minute. So X is the number of minutes. Y is the total cost. And then for the other plan, it doesn't depend on the minutes. It's just 200 all the time. So no X in that second equation. I'm going to do 7 and 8, and then I'm going to skip to the last two on this page, and then that'll be enough to let you fill in the rest and check the key. So Sue's coin box contains only pennies and nickels. She has 66 coins for a total of $2.38. So this is another one where we have two totals. Totals is green. Okay, so she has a total of 66 coins and a total of $2.38. And so my variables here are pennies and nickels. You can use P and N. P equals number of pennies. And N equals number of nickels. And so I don't know how many pennies I have. I don't know, or Sue has. I don't know how many nickels she has, but I know if I add them together, she has a total of 66 coins. A common mistake is saying P plus N equals 2.38. Remember, P is the number of pennies. That's going to be a whole number. Same with nickels. You're not going to have half a penny. You're not going to have 0.38 of a nickel. You're going to have whole numbers. And so coins plus coins equals total coins, and those are going to be whole numbers. To get the $2.38, you have to put the monetary amount times the number of penny. So a penny is 1 cent, so 0.01, and a nickel is 5 cents, so 0.05. Okay, a quarter would be 0.25, a dime would be 0.10, and so since we're just dealing with pennies and nickels, I'm just going to write those. 0.01p plus 0.05n equals a total of 2.38. So whenever you're writing these total equations, make sure your units line up. Coins plus coins equals total coins. Money plus money equals total money. Your units must line up for these. All right, last one on this page, and then we'll skip to the end. The perimeter of a dance floor is 44 feet. The length is 8 feet less than twice the width. Okay, and so once again, you only get two variables. What a lot of students do is they say, okay, length is L, W is width, perimeter is P. Don't do that, because P would be a third variable. What we need to do is write perimeter in terms of length and width. So I'm going to draw you a rectangle, and I'm going to label this the length and this the width. And so if I want the perimeter, I add up all four sides, L plus W plus L plus W. And so the formula for perimeter would be 2 times the length plus 2 times the width. Okay, and so when they're telling me the perimeter is 44 feet, they're telling me 2 times the length plus 2 times the width equals a total of 44. So that's a sneaky way of giving you a total. Notice I didn't use P in that equation, I used L and W. I only get two variables, L and W are them. Okay, and then the other equation is a comparison. It says the length is 8 feet less than twice the width. That's comparing the length to the width. Length comes first in the sentence, so L equals, and it says 8 feet less. So I'm going to skip a space and I'm going to put -8. It's 8 less than something. So I'm going to have to subtract 8 from something. And that something is twice the width. Twice the width would be 2W. So L equals 2W minus 8 would be my second equation. So notice my two equations only have L's and W's. That's all I get. I don't get P. I don't get any other letters in there. Okay, and then I'll save the next page for you, but I'll do 15 and 16 for you. So 15, you are collecting beetles. You have two types, dung beetles and Hercules beetles. You have 5 times as many dung beetles as Hercules beetles. You have a total of 24 beetles. So let's start with that total. I feel like totals are always the easiest. Okay, a total of 24 beetles, and we're dealing with dung beetles and Hercules beetles. Let's use D and H. D will be dung beetles, the number of dung beetles. And then H will be the number of Hercules beetles. So I don't know the numbers of each one, but I know their total, D plus H, will add up to a total of 24 beetles. Now, this next one is a comparison. You have 5 times as many dung beetles as Hercules beetles. Since dung beetles comes first in the sentence, it's going to be D equals automatically. And then it says 5 times. Okay, so 5 times the Hercules beetles would give me the more dung beetles. So 5 times H. This next one is similar, but I'm going to point out a difference between the two. Kiana and DeAndre are trying to decide how to split their tips after their shift at Outback Steakhouse. They know that together they waited on 36 tables. That's a total. And Kiana waited on 6 more tables than DeAndre. That's a comparison. Okay, and so we have Kiana's tables, so we'll let K equal the number of tables. I'll call them Kiana tables. Number of Kiana tables. And we'll let D equal the number of DeAndre tables. Andre tables. Okay, I don't know how many each of them weighted on, but I know the total, if I add K, the number of Kiandra tables plus the number of DeAndre tables, I get a total of 36 tables. Tables plus tables equals tables. Okay, and then this next one, you have to be very careful. It says Kiana weighted, so I'm going to have K equals 6 more tables than DeAndre. Okay, it doesn't say 6 times as many tables. A lot of people put 6D here, but if you told me you had $10 and I told you I had 6 more dollars, you would tell me I had 16. You wouldn't tell me 6D. It's 6 more, so 6 plus DeAndre's table. So I'm going to do D plus 6, not 6D. So in the previous example with the Beatles, it actually said 5 times as many. So 5 times H is the equation. The second one said 6 more, not 6 times. 6 more would be plus, and I guarantee you 6 times D will be an option. And if we're solving this, if you solve it with 6D, you're solving a wrong equation.